And these correspond to the values for 0, 0, 0, 1, 1, 0, 1, 1, right? That's what, and you're going to have an array, presumably, that's storing this, hopefully in that order. And what you need, if you're combining 2 qubits and 2 qubits, then you're going to end up with something that's storing 4 qubits, right? Right. So first you need to calculate how many spots you need, right? And so you're going to be able to do that. But then you just look, oh, 0, 0, 0, 0. That's AE, right? Because it's the probability of 0, 0 on the first two and 0, 0 on the second two. Oh, 0, 0, 0, 1. Oh, that's AF, right? Because it's still, all of these with 0, 0 at the front are A on the first one, and then the corresponding one on the second one. So I'm not going to do all of the work for you, but so you can see this pattern, right? Where we're drawing the first 2 bits from the left-hand one and the second 2 bits from the right-hand one. What you're going to do is you're going to find a pattern. And that pattern is going to tell you how your loops should be to do these multiplications, right? These are all multiplications. So I multiply A times F, A times G, A times H, and you're going to have a loop structure to perform the multiplications in the correct order so that the correct products end up in the correct index of the new array based on the index of the old array. Does that make sense?
So does that mean if you, for example, we're merging 2 qubits, at least of different sizes, then does that mean that the order in which the merge happens results in different resulting qubits then?
Okay, so let's say that this is a, well, let's not that. Yeah, let's say this is 2 qubits and 1 qubit, right? But you know which one's on the left and which one's on the right because you have 2 input arguments. One is on the left and one is on the right. Right?
Okay.
So you always know which one needs to be on the left and which one needs to be on the right. So now it's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So it's still going to be, it's going to be a similar pattern. So yes, so you should now take this second example, write out its pattern, and then that's going to allow you to generalize to any common, any situation because your loop bound, you're going to make your loop bounds general so that they can handle, it's going to be based on the number of qubits of the thing coming in.
Yeah, I was just curious as well if okay, this answers my question as well of like whether merging qubits with qubits of differing sizes is commutative or not. So at least it seems from this it's not commutative.
It's never commutative. Right. The order of the qubits is very, very important.
Okay.
And so the order in which you perform the products is critical.